Welcome to the dynamic learning hub of XLR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. The hybrid mode is a game changer as you can enjoy the benefits of a live classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Wanna get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. XLR. We don't just train, we build careers.
Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting
Good evening. Hope I'm audible. And the screen is also working. You can see that with the yes, audible, and the screen sharing is also working. Audible and screen sharing is working. Yes, yes, a small internet issue.
I think, sir, there is some issue with the network. The voice is not clear.
Sir, I'm at some other place, so just checking where I can. Now is it? Yes, sir. Now is it fine? Guys, now I'm audible. Okay, okay, yeah. So I'm at a different place actually. So if there is any audio issues, let me know. Maybe I'll kept my device on charge. So if it is not being audible, I'll go outside. I'll sit somewhere where I have proper signal. Okay. All right. So if you are facing any audio issues, do let me know. And welcome to day 13. Is it? What is this? Today is Wednesday. Yeah, day 12. Day 12 or day 13? Day 13. Sorry. Yeah, we have 2 more days after it, so we are in end game now. So let's go through cues as discussed earlier. Yesterday, we talked about Check on audible and visible. Everything is fine. A small confirmation. Audible and visible. Done. So as I was saying, I'm in a new place, so do adjust for today. Tomorrow I'll see a good location for class. Yeah. If there are any internet issues, do let me know. I'll be happy to repeat it again. So yeah, let's get started with interviews. So as I said, it's been a long time since we have seen the first presentation. Let's go back again. Let's only look at Q. Okay. So we are back to the first presentation again. And here. Now, what is a queue? Queue is also a restricted data structure where we will be inserting from one end and we will be deleting from the other end. Okay. The end where insertion happens is what we call as rear end, and the end where deletion happens is what we call as front end. Okay. You see, we all are familiar with it. A general queue, a queue at a coffee shop, a queue at a cinema theater, everywhere. Okay. All these data structures, they all came from our real world usages. Okay. So that's how we built all of them, and that's how we are using them in our softwares as well. Now let us say we have a queue. If I want to insert an element, insertion will happen at the rear end. Okay. The end where insertion happens is what we call as rear end. The end where deletion happens is what we call as front end. You say I'm inserting 10. Okay, I want to insert one more element, so I have to insert it from the rear end only. It will be inserted after 20. I want to insert one more element, it will be inserted after 20. That's 30 we have. And if I want to delete anything, the first element will be the first one to go. First come, first serve, first in, first out. That's how it will be. Okay, so 10 will be deleted. After 10, you will be deleting 20, 30, etc. Okay, so Q is a restricted data structure again. Take a linker list. We will see linker list implementation as well today. And we will also go through the array implementation for Q as well. And once we are done with both of them, we will talk about trees. We will see what is a tree. We will go through the terminology of a tree. We will go through in order, pre-order, post-order traversals of a tree. I told you to go through recursion a little bit, right? I hope you all have gone through it. So that's what we will be doing. So let's first implement a queue. We will implement a queue by using both arrays and linked lists. So we'll see two ways of implementing queue. Done. That's it. So let's get started. So as I said, queue is a restricted data structure. You need to perform insertion from one end and deletion from the other end. So let us go ahead with that. Okay. So first we'll talk about array implementation. Array implementation. Next, we will go with the linked list. Okay. Done. Now see here. First, how can we perform array implementation? How can we perform linked list implementation? How can we do that? So let's talk about an array. So how to perform array implementation? Any idea? Any idea? You see, if you want to add an element from the ending, we have l.append. So what this will do, adds an element from the end, adds an element from the end. Now, what about removing from the beginning? Okay, you can use l.pop. But this time you need to pass the 0th index. So 0th index means this will remove an element from the beginning. That's it. That's what we can happily use. Let us create a menu-driven program for it, and then we can get going with all of these things. Now I'll go with while true. So this will be true for infinite number of times. This will keep on repeating it. So while true, we will go. We will ask the user, to select any of the menu items. So we'll take an input only. We'll take it as choice. Choice equal to int of input. We will ask the user to select one for NQ. Okay. NQ means adding a value to the queue. We'll be having DQ, deleting a value from the queue. Let's go with display, displaying our entire queue. And what else we have? We can also go with length as well, length of our queue if you want. We can also go with other things. We'll go with exit maybe. Yeah, that will be fine. Queue is a basic implementation, so we'll not spend much time here. I hope you all have chat access. Just confirm, yes, you all have group chat access. Done. Right, so yeah, we are taking the choice from the user. If the choice entered by the user is 1, okay, then I need to perform NQ. So let us take a empty array as my queue. This is what we are doing, okay, right? So if I want to enter an element, first I need to take an element as input. So let's ask the user to enter an element. So element equal to int of input, enter element to, okay, NQ. Add it into the queue. So user will enter element, and I just need to use queue.append. This is going to add it at the end. So one end is, that is what we have as rear end. So let me just write down queue. You see, this is the queue we have. Okay, you can imagine it in this manner. Done. Right, this is the queue we have. So this is our front end. This is our rear end. You can always imagine. You see, I show a lot of visualization. Okay, those are a part of what happens in my mind, or whatever. Whoever is good in data structures and algorithms will do that visualization. But I'm just showing you. I'm able to show that visualization properly to you as a beginner. And if you are going to continue that moving forward in the future as well, you will be easily able to master DSA. Okay, you see how effortlessly, how easily I'm making a concept look. Okay, you just need to enjoy learning that particular concept. Okay, placement, all these things will come after it, but try to visualize it, try to understand what it's made of, what it's actually doing in that manner. Okay, as you add an element, it will be inserted from this point. It will be inserted from this point, okay, NQ, and it will be deleted from this point. Okay, that's how it's gonna be done. So it will be deleted from this point. That's how queue is going to work. So we have 10 here. So I'm entering 10. So 10 will be added from the rear, nothing but append I have to use. So queue, okay, queue dot append of element. So element will be added at the ending. What about deletion? Okay, so let's go with DQ. We have if, let's go with the LF. The character that you have entered is 2. Okay, if you are entering 2, then we will be deleting the table. Let's also display it. So deleted, we'll go with a small print statement. So print deleted. Okay, so what is the deleted value that we have? That is popping the first element. So again, internet connection is unstable showing. Good. Anyway, so you see, deleted, we need to delete the first part of our queue. Q dot pop of 0th index. And I hope you all remember, if there is an element, then only you can delete it. So we will also add that condition as well. So see here, if you can go with the length of the queue. If length of the queue is not 0, queue is not equal to 0, then only you will be able to delete an element. If it is equal to 0, then else print queue is empty. Okay, queue is empty. You can also take one more card, just like in as we have taken here also you can take one more variable card length. You can increment this up to you. So you can even go with this basic implementation as well. This is also fine. So purpose. So I'll copy it. I'll go with one more step. So if the choice is equal to 3, then I'm going to display it. Okay. So I'll leave this one as it is. If Q is not equal to 0, then only we can display. We just need to access each and every number and display them. They are in a sequential order. They are inside an array. So I'll just simply access them and print it for element in Q. Okay. We'll just print all the elements. We'll print element and equal to space. Or you can even display an arrow in this manner. Okay. This will be even better as well. Done. That's it. So that's about the third part. So displaying it, or we have length. So maybe we can take the extra character. You see, length is equal to okay. Whenever I'm adding an element, I'll increment the length. So if I'm adding an element, length plus equal to 1. If I'm deleting an element, length minus equal to 1. So length minus equal to 1. Now, when I want to delete an element, I need to check. The length should not be equal to 0. Instead of using the input function, we are just counting it. We are just storing it inside a variable. That's what we are doing. Okay, fancy nothing. Yeah, everywhere I'll be using that length only. And you can even display that starting from 0 to length. That's up to you, but this will be fine. This will be easier. So 1, 2, 3. Now coming to the fourth one, length. Since we have written it, I have changed it actually. Q is not that much important. Okay. One of the least important topics you can say, and very less usage in non-linear as well. Q, you will be using that for graph search in there sometimes. Very little usage of Q. One of the less important topics. Okay. So choice equal to 4, we need to print length of Q is equal to length. We are storing that inside a variable now. We are just printing it. Now, if the user enters choice equal to 5, okay. So if the user enters choice equal to 5, we just need to exit. We need to exit from here. We'll print program ended. Okay. And we can have break. You see, this is an infinite loop. Loop will end in two situations. First situation, if this condition becomes false. Second situation, whenever we come across break keyword. Since this is forever true, this loop will never end. This is going to continue up to infinity. So whenever we enter the choice as I, then break will be executed. Then we will come out of the loop. Okay. That's it. That's about these 5 choices that we have. That's about the Q implementation. We will also see implementing a stack as well. I'll give you some time since we have completed stack, since you have seen Q, and it's not that big deal as well. Let's how we are going to perform it. We'll run it. You see, it's asking us to interface. Maybe I want it in new line, so let me add a /n here. Okay, perfect. Now let's run it again. Enter a choice. Sorry, what happened? Terminal, yeah, now it's fine. First NQ, enter the element to NQ, 10. Again NQ, enter the element to NQ, 20. Again NQ, 30. NQ, 40. NQ, 50. Now let's go with 3. You see here, what are we getting? 10, 20, 30, 40, 50. I want it in a new line, so let me add one more empty print statement here. Okay, empty print, done, and deletion, etc. and all are fine. Done. Now anyway, as you can see, 10 to 50 we are getting Q. So I've symbolically shown that the first we removes 10, then 20, then 30, then 40, then 50. Now let's go with DQ. So first inserted element is 10. So first out. Then we delete it. Now display it again. You see, you will get only from 20 onwards. Okay. Now what is the length of the current Q? That is, length of the Q is 4. Okay. What if I press 5? 5 means exit. We'll come out of it. Now let's run it again. This time I made the change now. NQ 10, NQ 20, NQ 30, NQ 40. Now display the entire queue. 10 to 40 we have. Okay. 10 to 40 we have. Showing internet is unstable, but yeah, 10 to 40 we have. Next, what is the length of the queue? Length of the queue is 4. And what about DQ? If I DQ, 10 will be deleted. Now let's display the queue again. 20, 30, 40. Let's go with DQ again. Let's display the queue again. 30, 40. Let's go with NQ again. I'll enter 10 now. Okay. Let's display it. 30, 40, 10. That's it. First in, first out we have. You can go with the length. Length will be 3. And you can press on 5 to exit. This is what we call as a menu driven program. Okay. We will be having an infinite loop running. We will be able to select any option to perform it. Generally, we write these as functions. Okay. Since I don't want to confuse you, I'm going in this format. You can go with anything, but the concept will be the same. NQ means you need to add an element at the end of the list. DQ means you need to delete that element from the front of it. And what about the other part we have? Okay. Length, displaying, exit, all these things. That's it. That's about queue. Let's go with linked list implementation. Okay. You need to implement a queue by using linked list. Now imagine, let's do some scribbling. Okay. Imagine you have a linked list and you need to work it as a queue. Let's say you have taken the value 10. The first node that you have is 10. Okay. Let me try to draw it as a queue. Let's delete everything. Let's take a rectangle. Okay. Let's say this is what we have. Now, if I want to add an element, you see 10 we have. Now, how will this work in linked list? Same thing in linked list. You need to create a node with the value as 10 only. Okay. Done. Now the second element should be added after 10. Third element should be added after 30. So how you are going to do this in linked list? You see, first node is 10, second node, third node. Okay. So 20, 30, right? So this is how we need to, what happened? Why all this okay? Now selected the other pencil. 20, 30. Okay. That's it. That's what we have. So here we are getting 10 first. After 10, we are able to access 20. After 20, we are able to access 30. That's fine. Now, if you perform NQ, this is what NQ means. NQ means insertion at end. Insertion at end. We need to insert an element at the end of the linked list. Now, what about DQ? DQ means, you see, first element that will be deleted is 10. You have to delete the first element. You see, deletion at beginning. Deletion at beginning. This is DQ. Okay. You see, this is the rear end of the queue. This is the front end of the queue. So whenever you are performing insertion, you need to add it at the end of it. Whenever you're performing deletion, you need to delete the head node. That's it. So insertion at end you have to do and delete at beginning. So that's how easy it is going to be. Let's try to implement this one. I'll be writing this time as a function only. Let's see that. So yeah, for functions, you guys need to know about the class object. Yeah, fine. So we did not see any of it. So let's go with that. So let's create a class called node. Okay. Node is our user defined data type. So whenever you're creating a class by default, you're creating a new data type itself. So for now, think about it in that way. We have a special method inside class def _init _self. Whenever we create a node, by default, this will be called. Okay. When you're creating a node, you can take the default value of it, default next pointer of it. Okay. By default, these can be set to none as well. Right. Do not worry if you don't know about what is a class, what is an object, etc. and all. Okay. you need to have good idea of one programming language. Then only you will be able to get into that parts. But anyway, we are creating a class called node. Okay. Inside the class, whenever we call or create an object of it, by default, this will be called. Okay. You have seen a node. We have seen a node is divided into two parts. What is that? We have self.value that is equal to value that the user is entering, or we'll call it data. Okay. Self.data is equal to value. Now self.next, the next point we have self.next is equal to next. By default, value is 0. By default, next is none. So whenever I'm creating a node, this will be called automatically. Okay, that's how it is. Now we are creating a data structure called queue. So class of queue. Okay, that's it. Again, node is a data structure. It is structuring data into two parts. Queue is a data structure. It defines a specific way of arranging the elements such that they follow, okay, first in, first out. Okay, FILO, first in, first out. Actually, first in, first out. First inserted element will be the first one to be out. So queue you have. So whenever I create an object of queue, okay, I'm just taking the length. Length is equal to, it will be defined with 0. I'm not giving any value to it. By default, length value will be equal to 0. Okay, so that's how it is going to be done. So in this, we can create our methods. def, we can go with, and we have one more thing as well. Yeah, linked list we are using now. Done. So linked list, we need to also go with the head value. Head is equal to yeah, none. Let's try to do it in this way. Yeah. Self.enqueue we will call. Enqueue means, what do you have to do? You need to perform insertion at the end. So you all have seen how we can perform insertion at end. First, we need to find out the last node. Okay, how you will find out the last node? You need to start from the first node onwards. Okay, you need to keep on moving until you are present on the last node, right? So head and tail is one thing that you have seen. Generally, no, you will anywhere. As I told you, we will be finding the last node. You guys have seen it now. If current dot next is equal to none, that is the last node, right? So that is how we will be moving forward. So what we'll do is current is equal to self dot head. We'll be starting from the head while current dot next is not equal to none. Okay, we will keep on moving forward. Current equal to current dot next. So by the time we are done with this loop, this current will be present on the last point. I hope you visualize it from our linked list presentation. We are moving forward, okay, till we reach the node. Now, how do I know it's the last node? Last node is the only node which will have next point as none. Until we have it as none, we'll move forward and to current next. Now, this is one case. What if you don't even have a linked list? What if your head is pointing to none? So that's one case that we need to check. So here, if self.head is equal to none, if self.head is equal to none, then we don't have to search for the ending. That is the starting, that is the ending. So whatever new node we are getting, you see new node is equal to, we have the you can get a value as well. Let's say element equal to int of input. We will ask the user to enter element. So the user enters an element to enqueue. Okay, to enqueue. Now this element we are passing here, okay, into the new node. So element we are passing by default next is none, so you don't even have to do that. Now I've taken element from the user. I've created a new node with that element. So this is how visualization how to be doing right now. Okay. For now, I don't have anything in my queue. So self dot head. This is how we will be accessing a value inside a class. So self you have to use here. You see, currently it's pointing to none. Okay. Currently it is pointing to none. So we have some query. Yeah, just a second. It will be fine. If it continues, do let me know. Okay. Now I hope it's okay. Just for today, I cannot do much with limited resources here. Now it's okay. Now it's okay. Now it's okay. Mic testing 1, 2, 3. 1, 2, 3. Yeah, okay. Done. Yeah, sometimes it will happen. So we are going through the visualization actually. So it's just for today. I cannot do much with limited resources. You see, self.head is pointing to none. So I've created a new node. The value is 10. Okay, I've taken 10. I've created a new node with this 10. You see, this is none. This is some 2000 location. This is our new node. This all visualization should happen. So initially, we don't have any first value in our linker list. So self.head is pointing to none. Now I have created one node. So this is going to be the first node. If self.head is equal to none, then what should I do? Whatever node that you have created is your first node. So self.head is going to point to new node. That's it. If that's not the case, where do you have to insert that particular new node? You see, let's say this is one value. If I don't have a head, I have created one. Let's go with the other way. Let me clear all these drawings. Let's say I already have a linked list. This is the head. After 10, we have 20. After 20, we have 30. Okay. Now, this is how you have it. Now you have created a new node. The value is 40. I have to insert here. So you see where we're starting. We are starting from head. Is current.next equal to none? Is current.next equal to none? No, it is pointing to 20. Current equal to current.next. Is current.next equal to none? No, it is pointing to 30. Current equal to current.next. Is current.next equal to none? Yes, current is pointing to none. This is where I have to insert a new element. So what I do is I'll come out of it. I'll come out of it. Okay. Here I'm going to add it. So current.next is going to be equal to current.next is going to be equal to new node. Okay, then that link will be established. And we are not using tail here. So this is the same creation part, but without the tail. So this will even give you dates as well. So that's why I'm doing the full implementation of it. That's it. That is about enqueue. Okay. Once we have added it, you see added an element. So length equal to length plus 1. So self dot length plus is equal to 1. Length will be incremented by 1. That's it. So enqueue is done. Now let's talk about dequeue. Dequeue means deletion at beginning we need to perform. So def dequeue. Okay, let me write one single statement before it. Deletion at beginning. Now what are you doing here? Insertion at ending. Insertion at ending. That's it. So dequeue we have, self we have, done. Now you all know in order to delete an element, we should have nodes in order to delete any element, we should have at least one element. So this you can check in two ways. If your length is not equal to 0, then you can delete an element. Or you can go with the traditional way. Traditional way here also actually you could check length, but I did not I didn't go with it. So here you can check it. So dequeue, you can either use the length or you can go with the default way. If self.head equal to none, if head is not pointing to anything, you don't even have any element to delete. So that's one thing we can check. So if self.head is equal to none, then I'll say print queue is empty. Queue is empty. There is nothing to delete. Queue is empty. Otherwise, if self.head is not equal to none, then you will come here. You need to perform deletion at beginning. And I hope you guys are all thinking about the animation. You see, 10 we had, 20 we have, 30 we have. We have these three things. If I'm performing deletion at the beginning, means 10 has to be deleted, means head is equal to header dot next. That's it. Okay. Head equal to header dot next. That's it. That's how simple it is. So self dot head is equal to self dot head dot next. And before deleting that element, you can even print it. So dq or deleted, you can write dq'd self dot head dot data. You can even print the data. That's it. That's about dq. Now how to perform or how to go with display? Pretty easy, same thing. So def display, same thing as we have in our linked list one. So current is equal to self dot head while current not equal to none. While current becomes none, print current dot data. Okay, we'll print current dot data, comma end is equal to, yeah, q is represented in this way. Now let me add an arrow mark here. Now current equal to current dot next. Let me show you the animated way as well. I hope whenever you are doing something, you are visualizing it. So let me, yeah, I think maybe it's better to draw it again. Let's say you have three nodes. First node, second node, third node. Okay, I know these shapes are not good, but anyway, it just, now we have 10, now we have 20, now we have 30. Okay, done. I know I have written the arrows in different order, but it's fine. Okay, so this is our head. So current will start from head. Current equal to self. Is current pointing to none? No, current is pointing to address. Until current points to none, you need to access current dot data. Current dot data is, so I'll get 10 printed along with this arrow. Next, current equal to current dot next. Current will move to the next element. Now in current is not equal to none. Yes, current is pointing to 20. Access the data. Current dot data 20. Again this arrow mark. Current equal to current dot next. Okay. Again, current dot data. You're accessing 30. Current equal to current dot next. What is the next element here? Nothing. None. So now current is pointing to none. Now you will stop. So we will get the queue order 10, 20, 30 only. That's it. That's what we are doing here. Now, once we are done with it, since we have faced some issues in the previous one, let's add a small new line character so that everything will be good. Maybe we are breaking it again. No, there are, as I said, no lead code questions on Q. Q very limited. You will be using Q with non-linear data structures. Okay. So that is also very limited. As I said, one of the least important topics is going to be Q. Okay, I'll write that down later. But you see, we have display, we have Q, DQ, we have NQ. Okay, we have created a node as well. So that's it. If you have basics of object-oriented programming, you will be able to do all of this. Or even you can ignore the class, etc. I'm doing. This is all functions only. There is one simple new syntax that you are seeing, that is self dot. You can even ignore that as a beginner for to start listen how a data structure is made. This would be perfect. This is how simplest it can be. Okay, that's what I can think of. So display is done, DQ is done, NQ is done. We can also go with the length of it. So, okay, let me write it a little bit differently. We have an internal method called double underscore str double underscore we call it dund. Okay, and you see data structure is one of specialty. I explained DSA like none other. Similarly, one more specialty is object-oriented programming. I love object-oriented programming. I've struggled a lot with it, and I make it very easy. It will be very fun, okay, regarding object-oriented programming. Anyway, so this method will be called when we try to use print, when we try to use print q, okay? Or maybe we'll do one thing. For displaying, we'll write it in that manner. We'll keep it as length only. Let's go with length, okay? Or let me first show you these normally, then I'll hack them. Okay, let's do that. So whenever we go with length, we can just print without returning. So print self dot length. That's it for now, keeping it simple. So this is my entire queue data structure. Okay, created a node. Okay, I'm using linker list to perform insertion at ending. I'm using linker list to perform deletion at beginning. To replicate, I'm creating a queue from the linker list, implementing queue from linker list. You have seen all of them. Maybe you have some doubts related to the syntax. If you are not programming, it happens, but do not worry about it. Okay, so done. So now let's go with queue. Okay, let's create a basic queue. Queue is equal to, I'll create an object of it. Okay, you see I've created an object of a queue. Now, if I want to go with enqueue, q dot enqueue I need to write. First, I need to enter any element, enqueue. Again, if I want to go with enqueue, q dot enqueue. Again, if I want to go with enqueue, q dot enqueue. This is not a menu-driven program. We are doing everything manually. You can even go with that menu-driven program as well. That's also fine. Now, after entering, this is dq. After entering 3 values, I want to display. So I'll go to display. I'll go with display. I'll display everything. I can even go with length. So you can go with q dot length here, length function, done. Now after that, I'll go with dq, q dot dq. I'll remove 2 values, q dot dq. I'll remove one more value, q dot dq. I'll try to remove one more value. So since I have only entered 3 values, this should tell me that it is empty. Okay, now let's try to display this. Now run it. Enter element to enqueue 10. Enter element to enqueue 20. Enter element to enqueue 30. You see 3 times adding an element. Done 10, 20, 30. Now int object is not callable. So def length we have. Length. Did I make it? Okay, I named both the function and the method as same. Maybe I'll take it as L. Okay, here I'll check it. L. And when I'm doing dq, I need to delete an element. So else self dot L minus equal to 1. Okay. That's fine. So here I need to print it as self.l. Now things would be fine. Now let's run it. 10, 20, 30. Okay. So we got 10, 20, 30. This is how our queue is being displayed. 10, then came 20, then came 30. Now coming to dq, first we need to remove 10, then we need to remove 20, then we need to remove 30. And you see, if I'm trying to remove it one more time, it is telling no, queue is empty. I cannot remove an element. Queue is empty. I cannot remove an element. Okay. That's it. This is about queue implementation by using linker list. You can also implement a stack using linker list as well. Okay. You just need to perform. Deletion at the beginning and deletion at the beginning and insertion at the beginning only. That's it. So stack will be even easier than this. Okay. So this is about queue. This is about queue that you are seeing. I hope you can see the output as well. That's fine. That's perfect only. You don't have to worry about it. Right. So that's it. You can take a quick screenshot of this one. You can take a screenshot of this one to try it again on your own. Take a screenshot of this one. I hope you guys did that. Took a screenshot. Done? Yes. Now let me change some things a little bit. You see here, instead of display, let me try to go with print queue. Okay, print queue. Instead of queue dot length, let me try to use length of queue. Now these methods or this print queue is generally for list. If you are doing, you will be getting 10, 20, 30, etc. and all. Na? Okay. For length, you will be getting the length of the queue, right? So now we will be getting an error. Don't worry about it. I'll be modifying it. So I'll run it. 3 times we can happily enter the value. 10, we can enter 20, we can enter 30. Now you see, here it is giving me the reference. Okay, generally any object will give you its address, and addresses are hexadecimal values. Memory locations are hexadecimal values. We will be getting it in 0x only. Okay, now how can I make it print? How can I call this display when I'm going with print? Okay, how can we call it? Simple. Here you need to make it as double underscore str double underscore. Now here we have a catch. Whatever data that you are trying to print, we cannot print it. We can only return as a string. We can only return a string. Okay. We can only return a string. So double underscore str double underscore. So I'll concatenate everything as a string. The result is equal to empty. Okay. Instead of printing, I'll go with result is equal to result plus str of current dot data. Okay. And I'll even go with that arrow mark as we are using to symbolically show, right? That's it. So once we are done concatenating everything, I'll return the result. Now check out up to this part, str we have modified it. Length we will still get an error, but now check out this part. 10, 20, 30. You see, now when I'm doing with print, you see this particular function is being called. Okay. These are the magic methods. This is what we call as polymorphism, operator overloading, okay, in Python. So when I'm going with print, it's happily calling 10, 20, 30. Okay, let's also do the same with this length as well, length function as well. You see, length function internally, it will be called as double underscore len double underscore. So if you understand object-oriented programming will give you an idea about how the language is built from the internal. Okay, so return, let's return it. So return self.l. So when we are going with length, we will print it just like any other length function we use with list or string, etc. Now you see, now let's run. You see, earlier it is saying queue has no length. Now it will not give us that error. First 10, next 20, next 30. You see here, this time I'm using print. This I'm not calling the display, not calling this str. It will be automatically called when you go with display. And you see, we can only return a string. That's it. One string we have to return. That's why we are concatenating. Now, when you call length, this particular function will be called automatically. So we are using this like any other length function. Okay. You can even have a screenshot of this one with this error highlighted as well. Okay, earlier you will get that error, but now you will not get it. Okay, you will even get the output properly. These are the two things we have changed. What are the two things? The display function we have changed and the length function we have changed. Okay, display and length function we have changed. Done. Might be a bit too much for you, but fine. Since we are in the end game, we will go through some advanced topics, some out of the box syntaxes, etc. and all. There is a lot you can do in programming. Okay, and you guys are not like many of you have not even started development, but once you start it, we can create our own virtual world. Okay, it can be anything. You can even get into full stack. You can get into any game building or AR, VR, everywhere there is a lot of scope. Okay, we can do a lot more in programming, right? So this is just the starting point. You can do whatever you want. This is our own virtual world. Then that's it. That's about Q. I hope you understood about Q, and I think we can close it now. Now see this part here. See this part here. This is the normal menu-driven program queue implementation. I'll copy and paste it below. You can take a screenshot of that one as well. Okay. You can take a screenshot of that one as well. You see? You can take a screenshot of this one too. This one too. Screenshot of this one too. Done. You can try implementation of queue. You can try implementation of queue. Okay. Done. That's it. Now, is there any problem solving in queue? No, not much. Not much problem solving in queue. Okay, I'll even show you the queue category. Queue category in lead code. Let me close this presentation. This is not needed anymore. Now see here. Where do you find queue? You see we have queue here. You see one of the last topics that we have. Okay. If I click on queue, this will be always integrated with any non-linear, preferably graph. Okay, you will be seeing graph a lot. I can rate it with the difficulty. You can see here implementation of stack using queues, implementation of queue using stack. You can also do that. You can build a queue from stack. You can build a queue from, stack from queue. That's also possible. Okay. And whenever we are having any other question, for example, first unique character in a string, let's try to open it. Let's see if this is possible. Let's see the acceptance rate first. 65%. So anything above 65 is easy. Now, if you open the topic, we will always have something else along with the queue. You see, we have string, we have hash table, we have something called counting. So it is used with hash map actually here. Okay. Let's see what this is about. First unique character. Given a string, first find the first non-repeating character in it and return its index. If it does not exist, return -1. Okay. So find the first non-repeating character. Okay. You see L we have, L is not being repeated. Okay. Again here we have L is being repeated. O we have, O is being repeated. We have V is not being repeated. So what you can do is, let me frame a simple queue. Okay. You all have gone through hash map. So let us use a small hash map. So let's go with hash map. Hash map equal to, we will take a empty dictionary. I'll zoom in a little bit. First, I'll access each and every character. For character in S, I'm accessing each and every character. If character is in dictionary, is in the hash map that we have. If it is already present, then what I'll do is hash map of character, okay, plus is equal to 1. I'm going to make a hash map of character is equal to hash map of character plus 1. If you don't have one, okay, if character is not in hash map, then what do we have to do? Hash map of character will be equal to 1. Okay, if it is not there, we will have the count of it is 1. So first, we'll print the hash map. I know they wanted you to come up with the index, but as you have seen me coding for the last 12 days, that's not how I do with things. Ultimately, I'll be returning the final answer only. But for now, the most important thing for me to do is I want to count how many times each character is repeated. So as they said, if you observe, we are using a hash table or hash map, interchangeable, that word is. And we are using counting. This is a string topic only. Okay, all these three. Now I'll show you queue implementation as well here. For that, first you need to know about hash map. That's come up with the counting value. Now if I run this, you see here, this is what I'm getting as of now. Okay, L is repeated 1 time, E repeated 3, T repeated 1, C repeated 1, O repeated 1, D repeated 1. So what is the first non-repeating character? That is L. Okay, T is also non-repeated, C is also non-repeated, O is also non-repeated, but we need to come up with L. We need to return the L index. You can also check with the next one as well. What is the first non-repeating character? L2, O2, we repeated one time. Okay, so we are returning the index of it, right? So, yeah, let's go with AQ. So we have stored everything here. Done. When we are taking that particular character, we can even use a queue here, or maybe string also we will be accessing from 0 only. What can we do? Can I add it in a queue? Should I show it in that manner? Yeah, let's take a queue. Okay. So Q is equal to empty list. Whenever I'm adding or counting the element for the first time, then I'll be adding it inside my queue. Okay. The order in which I have encountered it, you can even simply use a string, that doesn't matter. But anyway, so Q dot append of ch. That's it. That's it. This is the order that I'm accessing them. This is the order that I'm placing them. Now, when we are returning, we also want its index actually. Should I use the method to search for the index again, or what should I do? That's a challenge. Anyway, we'll ignore that part. You see, now we have the hash map. Let's also print the queue as well. Okay. Queue will have the order in which the elements are coming, in which the elements are there. You see, first we have L, then we have E, then we have T, then we have C, then we have O, then we have D. Okay. Since we have E before T, that is the order. This is the queue. This is the queue. Now I just need to simply check if L count is 1, then I need to return its index. Or if E count is 1, I need to return its index. Whatever count is 1, I just need to return its index. That's all I have to do. So I'm just displaying that. So for your reference. Now for element in queue, you can simply go with this array only. You don't even have to go through that. Element in queue, if hash map of element, if the counting is equal to 1, then we need to return its index. So index, again, that's a issue for us. We are not storing that index. Maybe I'll just for this question, I'll just map it with the internal method called index. So we'll go with s dot index of element. Yeah, forgive me for this, but anyway, just leave it. If the element is not there, we need to return -1. So if there is no non-repeating character, we'll come out of the loop, we'll return -1. Let's try to run it. I'm confident it will satisfy all the test cases. I'll submit it. We should be able to get everything, 65%, so we should not be facing any issue. Yes, 107 out of 107 passed, but not the perfect way. Let's take out the solutions here. Let's see if anyone has used Q here. Okay, let's check out their way of implementing it. So they might have done it in our way with little changes, you see. He's also showing you just like me. First, he has taken a dictionary to count everything. Then he is finding the character with only one value. Okay. They have not used Q. I have insisted on using it. That's the only difference here. Nothing else. So just leave it. As I said, Q will not have much implementations in it. You can also see the questions. All these are normal, doable questions only. Yeah, just a second. All the other questions, you will be having them in sync with some other data structure. Okay.
For example, if I take this jump game 6, let's see the topics that we have. You see, that is included with dynamic programming. Heap we have. Okay. So this is different. This is different. So Q, basic implementation of Q, you will not be having it anywhere. We'll be having it with a combination of other things. Okay. That's it. That's the basic of it. Then, so let's go with implementation of Q using stacks. Okay. This is going to be the last question in queues. You don't have any other questions actually. Okay. They all are going to use Q as a, like you have seen the previous question, just like for counting purpose, for the order we will be using it. That's how you will be using it. So if you have gone through depth first search, breadth first search, you would have already seen it. Okay. Now see, implement Q using stacks here. Okay. And they have already defined your class called myQ. Your objective will be instantiated. It will be created and called in this manner. Object.push, they will pass a value X. You need to insert that element into your queue. Object.pop, you will need to remove the first element. Object.peak, I think you have to show the front starting element of the queue. Object.empty, you just need to return true if it is empty, otherwise you have to return false. Okay, these are design related questions. These are quite common. Okay, they will be asking you to design something. Interview based questions are these are quite common, and this is one of the easiest ones that you can get started. So see, what they are doing is we need to implement first in first out data structure using only 2 stacks. We have to take 2 stacks and implement them. So why 2 stacks? Because without 2 stacks you will not be able to implement it. Okay, stack is first in first out data structure first in last out data structure In order to make a stack as a queue, you need to use 2 stacks. Think about it. Okay, how to use 2 stacks and make it as a working queue. Think about it. That's what your assignment is. Okay, you need to implement these 4 things. You don't have to write the code for it. You just need to figure out what you have to do. You have 2 stacks. I have given you 2 stacks. You don't need to know anything about programming. You know the basic of stack. Okay, how can you use 2 stacks and make it work like a queue? If you can give me that description, I'll go ahead, I'll code everything. Okay, that's it. You must use only standard operations, which means pushing to the top, peak, pop. Okay, size is empty. These are the valid operations. Depending on your language, the stack may not be supported natively. And one more thing, we also have these stack and queue inbuilt in Python. Okay, you can also use them inbuilt, or even list is very basic. You can happily use list as your stack and queue. You will not be having that much difficulty. Okay, use list or queue. Queue means double-ended queue. Double-ended queue means from both sides we can perform insertion and deletion. Okay, that's it. So we will go with the normal list only. We will use a normal list as a stack only. That's it. And input, they will be giving you these type of commands. And you don't have to worry about it. I think it will be called internally. So this is only for our information. MyQ means this object will be created. Push means they will be giving a value that will be inserted into MyQ. Again, push means they will be inserting another value. So we have 1 and 2 inside our queue. Peak means the topmost element. Topmost element is 1. Pop means we have to remove 1. Okay. Empty means we have to come up with false. Okay. That's it. That's what we have. You see, peak means 1. Pop means 1. And empty means false, because we still have 2 into it. And push will not return anything. It is just adding it. Push will not return anything. It will just add it. MyQ will not return anything. It is just creating a new queue. Okay, you can see the explanation as well. So you can see push, your queue is added with one element. Push off to, you have two elements. Peek means what is the first element? We just have to return it, should not remove it. Pop means or DQ means we have to remove it. Okay, Q is 2. Now empty means you just need to return true or false. See the constraints, how many X values will be given, how many inputs they will be giving you? 9. Okay. At most 100 calls will be made. Okay, X value, what is this X value? I think it's the value that we are inserting into it. Yes, the value we are inserting into it is X. So that is going to be from 1 to 9. And you will have at most 100 calls. Okay, they will do that automatically. You just need to finish this implementation, which I will be doing. You also can come here and fill these functions. So I want you to describe how we can use two stacks to be implemented like a queue. How can we use two stacks to be implemented as a queue? Again, I'll be giving you some time. I'll also drink some water and come back. I'm getting some cough. So you see, you have 5 minutes. I want you to think about how we can use two stacks to implement queue. Okay. Question number 232. Right. I'll make the chat to host and co-host. I want you to think about it. Ignore all the other stuff. Very simple question. Take two stacks. Okay. You need to work with those two stacks. You need to make a queue out of it. How can we use two stacks to implement queue, to make it work like a queue? Think about it. Take a first in, last out data structure, make it first in, first out. Take two first in, last out data structures, make it first in, first out. Yeah, 4 more minutes. I'll drink some water, then I'll come back in 1 minute or so. I hope you will be giving me some paragraph. Okay. I'll be waiting. I'll be waiting. You have 4 minutes. Yeah. So I'm back after 1 minute. I've received a message from Kushi. Mm, mm, we'll use stack 1 for enqueue. Then if stack 2 is empty, we'll pop all the elements and then push them into stack 2. No, maybe. I'll come up with an example of how it will work. Try to come up with an example. Try to visualize it. You have 2 more minutes, almost 100 seconds now. Okay, 100 seconds. Yeah, I think Kushi.
Very good. Kushi got it. Kushi got it. Kushi gave us the correct answer. Okay, perfect. Done. Well done. Hmm. Yes, yes, you got it. It's correct. Okay, so Kushi got the points. Again, 40 seconds more. I only got one response. How can you use two stacks to make it work like a queue? To make it work like a queue. How can you use two stacks to make it work like a queue? Again, not much response today as well. You guys are responding very slowly these days. Anyway, fine. I understand this might be very new to you, but fine. We'll continue. So see here, as Kushi said, we will take two stacks. So self dot S1, we will take stack 1 equal to again, self dot stack 2 is equal to empty. We will start with two stacks. You see, the idea is pretty simple. Idea is pretty simple. Let me scribble it. Let me do some doodling on the screen. Okay. Idea is then we have a queue. Okay. When I want to perform insertion, you see, this is my same stack. I hope we have good internet connection. Yeah, I think internet will be fine now. Let me make it a bit darker. Why are we getting it in this manner? Yeah. Let's say we have our queue. Okay. We have our stack. We will take two stacks. We'll take S1, we will take S2. I have added a single element, 10. I have added 10 here. I have added one more element, 20. I have added one more element, 20. I have added one more element, 30. Added one more element, 30. So addition operation in stack, we will perform push. Okay. Here, whatever you are enqueuing, we will use the stack to push. Now for deletion, see, I have to delete 10, but here in order to access 10, you need to remove 30, you need to remove 20, then you need to remove 10. So what I'll do is, I'll use this second stack, whatever element that I am removing from the stack 1, I'll store it in stack 2. Whatever element that I am removing from the stack 1, I'll store it in stack 2. Whatever element that I am removing from the stack 1, this is the first element now. You can even store it here. Okay, if top is equal to -1, etc., whatever we did earlier, you can happily delete it. Okay, when the next time when you're pushing everything back again, you will be accessing 20, then you will be accessing 30. That's how you can again use it. So simply we will be using one queue for performing push operations, sorry, one stack for performing okay, NQ operations. Whenever we want to delete any element, we will be using the other stack to reverse all of it to remove the value that we are looking for and then continue forward again. Okay, that's how it is. So let's do that. So whenever you're doing push, so what do we have to do here? Let me zoom in. Push means I'm using stack 1 to push everything, append of X. S1 dot append of X, and this is self actually. Self dot S1 dot append of X. That's it. Now, when we are trying to pop anything, okay, first we need to check if S2 is not empty. Sorry, if S2 is not empty. Mm, what should we do? Pop, we have to move all the values from
S1 to S2, and then yeah. Yeah, let's do that. So while while S1 is not equal to empty, you can write it in this manner. Okay, while S1 doesn't become empty, or length of S1 also you can do all the stuff. We will pop S1 dot pop. We will pop the last element. We will append that as new element in S2. S2 dot append of S1 dot pop. Okay, this will keep on repeating until we have all the elements removed. Now we just need to pop the last element. We just need to return. We just need to return. Once everything is done, we just need to return s2 dot pop. Let me show you how this works. Okay, I'll take a 10-second pause or so just to visualize what I wanted to achieve and what I'm actually doing there. So let's say you have 10, you have 20, you have 30. This is your queue. This is S1. S1 is filled with 10, 20, 30. Okay. Now S2 is currently empty. Now while S1 is not empty, is your S1 empty? No. S1 dot pop, remove 30, add it into your S2. Okay. S1 dot pop again, remove 20, add it into your S2. S1 dot pop, remove 10, add it into your S2. Right now S1 is empty. Yes, S1 is empty. I've removed all the values. Now they asked you to pop anything. So pop 10. So if we pop 10, that's it. I'm just returning it. So this will not be available here. So the last values I'll be having in both my stacks is this one. That's it. 20, 30. Now we can again place all our S2 elements back in it as well. Okay. We can place all our S2 elements back in it as well. So while S2 not equal to empty, you can also simply write it as while S2. This is the beauty of Python actually. This line and this line, both of them are exactly the same. Okay, in Python, you don't even have to write that. That's how easy it is. So if you are a beginner, getting started with Python will make it easy. So what do we have to do? While S2 is not empty, S1 dot append of S2 dot pop. Okay, pop S2 value, append it in S10 value. That's it. Everything will be fine. Okay, we are using return here now. This is going to be an issue. We need to perform this before only. Maybe I'll yeah, that's why I wanted to write that. If S2 is not equal to empty, if S2 is equal to empty, then we can perform these. If S2 is not equal to empty, means it already has the implementation here in this manner. Okay. So let's try to do some more simulation. Okay. Let's say 10 is deleted. Now I want to insert 40. So I'm inserting 40 here. Okay. I want to insert 50. I'm inserting 50 here. Right. And now if I want to delete something, how will be that order? If I want to delete 20, these has to be added back here anyway. They have to be added back here. Added back here, or I want to delete it. We have 50, we have 40. This is not the order generally. Okay. Mhm. Returning, maybe we can save that inside a value and then return it. Yeah, that would be a good thing, maybe. Let's try to do that. So before, yeah, we'll do one thing. Let's not return it here. Okay. So let me modify this to our earlier code. Done. Now we'll say popped value. Okay. Popped value or value is equal to self dot s2 dot pop. This is self actually. Self dot s1. This is also going to be self. So I'll go with self dot s2 dot append. This is also self dot. So I've stored the value. Okay, the value I have to remove inside value here. Done. Now, as we have discussed, we will pop out all the elements of s2 while s2 is not equal to empty. Okay, we just need to add s2 dot, sorry, s1 dot append of s1 dot append of s2 dot pop. That's it. So our first list will be fine. And once we are done, we can even return the popped element. So return value. So let me show you how this works. Okay. How this works. You see, we have our queue 10, 20, 30. Don't mind the drawing. I have used the first list 10, 20, 30. I have used the second list. This is empty. Now, while S1 is not equal to empty, while S1 is not equal, recording stopped. Okay, maybe there is a small glitch. Yes, while S1 is not equal to empty, pop 30, append it inside S2. Pop 20, append it inside S2. Pop 10, append it inside S2. So what will happen? 30 is deleted, 20 is deleted, 10 is deleted. Okay. Now the value I have to remove is 10. It is stored inside value. Value is equal to 10. That is also popped. Okay. Done. Now I'm again repeating all of this. I'm not returning it. I'm again pushing back all of this. So 20, again I have popped it, I have pushed it. 30, I have popped it, I have pushed it. So 10 is removed and your queue is in safe process. Okay, is in the same process. After 30, you can add 40, you can add 50. If you want to delete again we will juggle it. Okay, we will pour all these values into S2. We will remove the topmost value. We will again pour all these values into S1. So this process will keep on repeating. So that's it. That's how simple it is. Okay. We did some brainstorming and that will be fine. Generally, I don't remember any of these solutions. I go on the go. So sometimes it will take me a while. Okay. Push is done. Pop is done. Now what about peak and empty? What about peak and empty? Empty is also fine. So we can simply do one thing. If S1 dot, sorry, self dot S1 actually, self dot S1 is equal to empty, then we need to return true. You can also keep this as return. Return self dot S1 is equal to empty, then it is going to be true. Now what about peak? Peak means the topmost element. Topmost element means we need to again perform this. We need to again check it out. Okay. So copy this, paste it here. This is a long shot, but we will not be removing anything. Okay. We should not remove anything. We should not remove anything. So top value is equal to S1 of -1. Okay. The topmost value of -1. So here we'll have to return top value. Top value. We got a message from someone. Attendance, I'm not the person you have to contact for attendance. I'm only here for doubts. Okay. That's it. I think we are good to go. Let's correct the syntaxes if I have used S2 or S1 plainly anywhere. So self dot S2 self dot s1 dot append. This is going to be self dot s2 dot append. Self you have to write everywhere. Self dot s1, self dot s2, self dot s1, self dot s2. Right everywhere self, 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 self. So, okay. This is also done mostly, I guess. Okay. Let's try to run it. Let's see if there are any issues with the code. We'll try to analyze and submit it as we are getting index out of range. Okay. Why index out of range? Okay. S1 of -1. Are they giving me anything? No. S1, S2 I'm taking. Top value is equal to S1 of -1. If it is empty, I cannot return anything. So that's one thing. Let's do that. Returns true if queue is empty, otherwise false. Returns the element at the front of the queue. If the element is not present, then what should I do? Sorry, I'm remove. So this is S2 of -1. Okay, my bad. S1 we are making it empty now. So it will be the topmost value in S2. Run it. Everything is fine so far. Okay, is it sample test case accepted? Let's submit it. Hidden test cases will be also fine. You see, 100% it is. That's how it is. You can easily solve it. You can take a screenshot of this one. You can take a screenshot of this one and try to implement question number 232 as well on your own. Okay. Right. Amar sir will be sharing it. Don't worry. You have time up to the end of the session now. You don't have to worry about attendance. So that's the least thing you should be bothered about. Do take a screenshot. Take a screenshot of this one and try out implementation of queue by using stacks. These are design questions. Design questions are very popular in OA, online assessment. They will be asking you to design something. Because once you join in a company, generally they would go with, lot of design process. You need to design a custom database. You need to do a lot of designing things. Okay, so you will be having these questions. These are some of the most common ones. Okay, and very easy ones, very fun ones. So I hope you took a screenshot of this one. 232 it is. This is what we have solved today. Right? So how much time are we left with? Okay, we are only left with some time. 20 minutes. Yes, we will get started with trees. We will talk about trees. Tomorrow we will go through the implementation of trees as well. Okay. That's it regarding queues. And one more thing. If I have to list out all the data structures, see how it's going to be. If you have to solve everything, okay. On a scale of 1 to 10, I'll rate them. You see, linked list is one of the easiest. Okay, is very easy. You have 20 questions in total. Only 20. Or if you include everything, only 20. And this also we have models. We have discussed all those models. You can get back to our linked list question and you can go through dummy node, fast slow pointer, previous current pointer. You will understand everything. That's one thing. This is easy. And now stacks are important. Stacks are important moving forward. We will be using stacks a lot in the future. Okay, so this is important. Now queues are super easy. Now queue is not important, not at all important if I have to say as of now. Basic implementation will be fine. Okay, not important. No questions. Okay, no questions are even there. So queue is the least important one. And then we have trees. Then we have graphs. These are very important. Okay, even more important than linked list and stacks. You can rate them even higher. And these are basic data structures only, and we have arrays and strings. We use dynamic programming. We have greedy algorithms. We use sorting. We use different algorithms. Okay, with arrays and strings. So as you can see, the order as well. Okay, in lead code, if you explore the order, this is the most asked questions in online assessments and all. First, you will be having arrays and strings because they have the hash table, they are using dynamic programming, they are using sorting, they are using greedy. Okay, all these are being performed on arrays and strings only, so they will be on top. If you observe everything, the least used data structure that you are getting is queue. Okay, after queue you are not getting much, you are getting binary search tree, which is a part of the tree. Okay, that's usage is different. So a full-fledged data structure is queue, you don't even get any of it. And you see, doubly linked list is there. As I said, singly linked list is the most difficult one, doubly is the easy one, so you don't even have to consider that, and rest of the things are very easy. So queue you don't even have to consider. Okay, the most important data structures are arrays and strings. By using hash table, we will be able to reduce the time complexity. So that's the next one. We have a lot of math-based logic. Okay, math, you have some other questions. These have basic questions as well, so you don't even have to consider that as that good. Lot of bit manipulation will be also involved in it, so that's why we have a lot of questions. You see, do we have any bit manipulation? Yes, 276. Next, dynamic programming. Next, greedy algorithms. Next, DFS, binary search is there. All these is how you are getting it. These are the most important to least important. That's how they are being asked. Okay. Linked list, as I said, not that much important. 20 questions will give you all the concepts of linked list, and even whatever questions we have solved, those are good enough. Those are model questions. You take those model questions, try to complete other questions on your own. Okay. Done. Done. So you have the attendance link being posted multiple times, okay, in your chat. So you can access it. We'll post it again by 9. Okay. Or maybe I'll make it enable for everyone, meeting group chat. You guys can share attendance as many times as you like. I'll not interfere in it. Okay. So I'm only here to deliver the lecture. Do not ask me attendance links. Yeah, you guys can keep on going with it. Right, that's it. Let's go with some basic tree terminology. Let me search for one of my old presentations. Okay. We will go with basic tree. Basic tree. We'll go with my CNDS. Where is it? I did not keep tree here, I guess. We'll see that. Yeah, we have trees. Done. You see, coming to trees, trees are nonlinear data structures. They will be connected to multiple other nodes as well. Trees can be represented in a hierarchical order. Okay. So there will be more than 2 nodes that will be connected. Coming to a binary tree, it will be containing only 2 connections at most. Okay, 2 children at most. That's what I mean by connections. So let's see some terminology in this. So as I said, binary tree means you will be having 2 connections, 2 children at most. So you will be having left and right. So that's a binary tree. You see, this is the example for a tree. We have the root node, and we have the left subtree, and we have the right subtree. If you have at most 2 children, that's what we call as binary tree. By means 2. Okay, 2 children you are having. That's what. This is the basic terminology. Okay, you can have multiple nodes in a tree as well, but we are just seeing binary tree here. Coming to root node, that is the starting point of your tree. This is the starting point of your tree, the first node that you have. That's what we call root. Okay, what is the child? Child means everything will have a parent and child relationship. Okay, the child of the node C is F, the child of the node A is C and B. So that's what we call child. So parent. Okay, so parent node. A is the parent node for B and C. C is the parent node for F. B is the parent node for D and E. Okay. What is leaf node? Leaf node means a node which has no child nodes. Okay. If you observe, kind of like a tree. From root it is starting. We have branches. Then we come up with the leaves of it. So if you observe, at the ending of your tree, for F, for D, for E, they don't have any children in it. So that is what we call as leaf nodes. And what are siblings? Siblings means, if you observe D and E, they have the same parent. B and C, they have the same parent. Those are what we call as sibling nodes. Okay, siblings. Your parents will be the same. Okay, so that's it. Ancestor. Ancestor means see, grandparent, parent, and child relationship. A is the ancestor for D. D is the descendant of A. So A is the ancestor and D, E, F are descendants of A. Okay. Now level in the sense, you see, they will be counting the level in the sense, I'll just mark it here, okay, with a different color. This is first level, second level, third level. Level counting can be 0, counting can be 1. In multiple questions on multiple books, it will be in different ways. Generally, it will start from level 1, etc. and all. So that's how it will be. Okay. So I think attendance is not changing now, the link. Every day it's the same link. Yes, correct. Is the Google form same for every day, or every day it is a new form? Is the link same every day? So then you guys can happily save it and fill it now. Why every day you are waiting for the attendance link and asking it multiple times? If it is the same link, save it somewhere in your WhatsApp chat also. Okay. Then what's the issue? You guys are shouting about attendance. Right. So yeah, binary tree will be having that hierarchy. A root node, left subtree, right subtree we have. Okay. This is how a binary tree will look like. As I say, we will be creating 3 nodes. You see, I'll just draw it. Tomorrow we will go through a good idea of it. This is our node. Node will be divided into 3 parts. The first part, we will be having the previous node address or the left subtree address. The second part, we will be having the data. The third part, we will be having the next node's address, or you can say this as left subtree, right subtree. This is the node value. Okay. Doubly linked list. You might have seen singly linked list. Here we are using doubly linked list. That's how it is going to be. Okay. Done in that manner. Now we have other terminologies as well. What is full binary tree or strict binary tree? What is complete binary tree or what is skewed binary tree? Okay. You see, full binary tree or complete binary tree. Okay. Full binary tree in the sense, at every level, if you are having strictly either 0 or 2 child nodes, that is what we call as a full binary tree or strict binary tree. You can see this example. At every level, you either have 2 or you either have 0. That's it. Okay. That's how a full binary tree is. Now see the complete binary tree. It is a tree in which all levels are completely filled except the last levels. If you observe a complete binary tree, every other level will be completely filled except the last level. Last level is the only one which will be a bit empty, okay, which will not be completely filled. Now what is a skewed binary tree? Kind of like only left tree or only right child you will have. So it looks like a linked list. You can see skewed binary tree. That looks like a linked list. That's the main observation. So skewed binary tree we have. That's it. And we have some tree traversals. We have pre-order traversal, in-order traversal, post-order traversal, level order traversal. Okay. Pre means before. Post means after. In means between. You have seen prefix, postfix, infix, just like that. Here, the main thing that we are talking about is node. Okay. A is the root node. B and C are its children's. Okay. if I only have this one, let me give you a smaller version of it. Let me go with pre-order, post-order, in order in a basic level. Okay. If I am taking the root node, if I am taking B, if I am taking C, okay. Pre-order means first I need to access root node. Always the order will go from left to right. So first root node, after left subtree, then right subtree. Okay, this is pre-order. In order means root node will be present in the middle. First left subtree, then root node, then right subtree. Post order means first left subtree, then right subtree, then the root node. Okay, this is pre, this is in, this is post. Now level order means first level, then the second level. So A we have, B and C we have. Okay. For this basic one, they all are looking like the same. For example, A, B, C and level order are looking the same, but it's not the same. This is only basic level. Tomorrow we will be talking about pre-order, in-order, post-order. I'll even implement them and show that to you. Maybe we'll not be implementing it. We might not have that much of time left. We will take Geeks for Geeks question or this lead code question. Let's see if we have any tree traversals in it. Let's go with pre-order. Okay. Let's continue from, binary tree, pre-order traversal, post-order traversal, etc. We already have questions here. We just need to go with the recursive logic. Okay. They will already have a tree ready for us. We just need to perform the traversals. Okay. So we will perform that operation. Done. That's it. That will be it for today mostly. We cannot stop it in the between. Pre-order, post-order. These will take at least 15-20 minutes. We only have 8 minutes. That will not be enough. So any queries you have till now? Any queries you have till now? We have completed queues. We have seen one simple implementation of queue in one of the questions. We have gone through array implementation, linked list implementation. We have gone through stack implementation of queues as well. We have used two stacks to be representing a queue. Okay. Any doubt up to this part? Anything that you want me to repeat again? Any doubt up to this part? Anything that you want me to repeat again? Any doubts? Any doubts? Any doubts? Now your homework tomorrow is go through recursion. Okay. Homework. What's your homework? Homework is practice and revise. Practice and revise recursion. Okay. Practice and revise recursion. In order, pre-order, post-order, we will only. Okay. So you need to practice and revise recursion. If you still cannot do that, we already have our lecture recorded. Okay. So I would suggest you to go back to YouTube and watch it. I hope you all know the XLR's YouTube channel. Okay. YouTube, you can find it. We have all our classes recorded in it, so you don't even have to worry about that. Go back and watch recursion. That's one of the best lectures on recursion that's available on YouTube now. Okay? So you can check it out. You can type for XLR YouTube. You will be able to get that. My internet connection is unstable, it's saying. But anyway, that will be. So tomorrow we will be going through trees, pre-order, post-order, in-order, traversals and all. Maybe if there is any simple questions, I'll try to add 1, 2 of them. Okay. So go back and watch recursion again. So you can open XLR, you can subscribe it, and then you can go through the live sessions that we have and check out the recording on recursion. Okay, it's taking much time, but anyway, you get the point. That's it. So tomorrow and day after tomorrow. We only have 2 days. Tomorrow we will completely, full-fledged, we will go through trees. Day after tomorrow, we will go through graphs. Okay, you see live session is going on currently. If you click on live, you can
So I got disconnected. So I think that will be it for today. We'll continue tomorrow. Okay. Bye bye. Bad internet connection it is. So excuse me for today.